Welcome to The Explainer. So today, we're looking into a modern-day treasure hunt, and it's happening literally right under our noses. We're talking about the hidden treasure locked inside our broken computers and discarded gadgets. We're going to explore the absolutely fascinating process of extracting gold from electronic waste. And we'll answer the ultimate question, is it actually worth it to try and recover it?
Real gold in e-waste? I know, it sounds kind of like an urban legend. But I can enthusiastically confirm that everyday items, stuff you probably have sitting in a junk drawer right now, like old computer motherboards, RAM sticks, processors, even broken phone parts, they contain actual gold. Yes, that broken computer gathering dust is hiding real treasure inside of it.
Okay, let's dive into this. Why on earth do manufacturers use such an expensive, precious metal in everyday electronics? Well, there are strictly practical, scientific reasons for it. They use tiny amounts of gold, particularly for connector pins, because it possesses two incredible properties. First, it conducts electricity extremely well, which is absolutely crucial for lightning-fast data transfer. And second, it doesn't corrode easily. It really holds up against time and the elements, meaning those critical connections are going to stay reliable for the entire life of the device.
But of course, you know there's a catch, right? The main challenge of our quest is a pretty significant one. The obstacle here is that the gold layer used on these components is exceedingly thin. We're talking microscopic. So even though these parts look incredibly valuable when you zoom in on all those shiny gold-colored connector pins, the reality is definitely a bit more daunting. To recover enough gold to actually amount to anything substantial, you need a massive amount of electronic waste. It really begs the question, just how much gold is actually hiding in a standard batch of parts?
Well, let's find out. Part 1. Preparing e-waste. Step-by-step sorting. So this isn't just about smashing up old keyboards. It's a very meticulous procedure. Step 1, you have to collect all those old computer components. Step 2, you carefully separate the specific gold-plated sections from the rest of the plastic and base metals. It's a highly targeted sorting process. In Step 3, which is absolutely vital for any scientific experiment, you have to weigh everything before the recovery process even begins. Recording that starting weight, like the 12.35 grams you see here, is really the only way we'll know if our final yield is actually impressive or just a drop in the bucket. Actually, hold on a second. I need to pause our treasure hunt for a very serious narrative speed bump. Do not try this at home. The process of industrial gold recovery is definitely not a weekend DIY project. It involves highly corrosive chemicals and toxic fumes. This kind of chemical extraction must absolutely only be performed by trained professionals operating inside a properly equipped laboratory with advanced ventilation and safety gear. The stakes are incredibly high, so we leave this specific extraction to the pros.
Part 2. Chemical process. Extracting the gold. Now, what's really interesting about this slide is how we pivot from mechanical sorting to actual laboratory alchemy.
This is where the cinematic chemistry happens, safely controlled behind lab glass. In the laboratory, specialized chemicals are used to completely separate the surrounding metals. The base metals are separated out, and the gold is completely dissolved. But here's where it gets wild. That dissolved gold is then chemically precipitated back into solid particles. It settles out not as shiny jewelry, but as this weird, dark, powdery substance. It's a stark, almost unbelievable contrast between the bright, shiny metal we saw on the computer board and this strange, dark powder. But make no mistake, that powdery material is exactly where our gold is hiding.
Which brings us to the moment of truth. Part 3. Was it worth it? Science versus finance.
After applying heat, purification, and refining to that dark powder, here it is. A real, tiny piece of recovered gold. An actual gold bead, literally born from the ashes of broken motherboards and discarded processors. Seeing that transformation complete is nothing short of incredible.
And this brilliantly illustrates the ultimate reality check. If we weigh the cool factor against the actual processing costs, the results are pretty clear. Scientifically, fascinating. I mean, we extracted a precious metal from household garbage. But financially, at this small scale, considering the intense labor and chemical costs, it simply isn't worth it. That tiny bead of gold doesn't even come close to covering the time and resources spent.
But wait, let's look at how this builds when we look at the bigger picture. Because the industrial reality is quite different from our small-scale experiment. Large recycling facilities aren't just processing a handful of RAM sticks. They're processing tons of electronics at once. When you scale this operation up massively, it completely flips the financial equation. It literally becomes waste in, wealth out.
The sheer volume makes the recovery of these valuable metals highly worthwhile and economically viable on an industrial level.
So, the crucial point is this. Let's bring the stakes right back to your own home. Before you casually throw away an old phone or toss a broken computer into the trash, remember what we've seen today. Those items contain gold, silver, copper, and other incredibly valuable materials. There's hidden value sitting right there in your junk drawers, just waiting to be properly recycled and reclaimed by the facilities equipped to do it.
We tracked down the gold, we learned the incredible science behind the extraction, and we uncovered the massive industrial scale required to make it profitable. But knowing that our everyday devices are packed with a whole periodic table of precious metals, well, it leaves me with one final question for you. Should we try recovering silver next? Let that sit with you. Thank you so much for joining me for this explainer, and keep your eyes open for the hidden science in the world all around you.